So this is the 5th session on the topic music through MATLAB, and what we are going to do is to study how to use the ADSR envelope in generating musical notes. Alright, so let us start, and first thing we do is to revise our knowledge of half sine wave which is used for envelope and the ADSR envelope. So this is how the half sine wave envelope looks, and you can see that there is not much flexibility in this. It starts at 0, ends at 0, and in between reaches a maximum. So the only thing you can really do is probably decrease this maximum value a little bit. But if you look at the ADSR envelope, you got much more flexibility. You got many phases here. You have the attack phase, you have the decay phase, you have the sustain phase, and you have the release. So you can change the duration of the attack, you can change the duration of the decay, that of sustain and release. You could also change the slope of the sustain phase. So there is much more flexibility in this. So what we are now going to do is to see how to use this ADSR envelope in generating the musical note. This is the original function that we have already studied, which we called as note G1, and this is where the envelope is generated. Then this is the sine wave, and this is where the sine wave is multiplied with the envelope. Now you want to make a change in this so that the envelope is different. So at this point you have to make a change. So let's rewrite this function. But since we are making a change, we are now changing the name of the function. We now call it note G rather than note G1. Then the rest of the function is identical, except that after definition of the time vector, we now use the envelope function. And remember, this envelope function generates the ADSR. Only thing, also remember that while generating this ADSR function, it could be that the number of samples in A are slightly different than the number of samples in T. Since they need to be made equal, we use the equal function, so that after executing the equal function, the number of samples in A and T are same. And now we generate the sine wave and again multiply the envelope with the sine wave and return the note. Okay, so that is the modified one. So let us now see how to generate a melody. Again, this is the program we have already studied, and it's the same program that we are using, except that in our previous example we had used the function note G1, which was having a half sine wave for the envelope. We now use consistently note G, and then it is the same melody, only thing it will sound slightly different. So let us see how it sounds. So first let us play the notes when they are generated using half sine wave. And now with the ADSR envelope. You can note that there is emphasis at the start of the note because of the attack phase in ADSR, and this demonstrates the difference between the musical notes when they are generated with half sine wave and when they are generated with ADSR envelope. And in our next session we shall see how to further change the quality of this note by using more complex waveform than sine wave. But for now, that's all.